due to some electrical problem.
Okay,
That is
no
what
issue.
has happened.
Continue, sir.
Thank you very much, sir. Thank you. Okay, today we have to start with that potentiometer, right? So as I said yesterday, this is the technical process that in which you have to uh, see so many things, right? It is the purely application factors, potentiometry. So under that, first we have already discussed about the potentials. That is, what is the potentials? Already I told you how it happens. Yesterday, that one question was there. Do actually that I have done one numerical also, right? If you have gone through that the assignment which is provided by today in the group, right? So one of the students who was shared with you, so in that there is some numerical. If I that if you want to start from that one only, okay, let's just a second please, let me find out that. Okay, just a second. So if you have that, you are in that the student, those have made that the group one, that is your assignment is there, right? So you have gone the compiled assignment for the all the portions areas, and it will come down to the MCH-4. Okay, MCH-4, and the question number 1A and sorry, bit question number A, bit I and double I. If you let's check your WhatsApp, and in that group some student has shared this assignment, compiled assignment. Why I'll start with that one. Yesterday also I started that numerical. Okay, so that's why the thing is that so see that numerical is there. I'll do the exactly. If you see a copper, that one question is there in cell potential and all the things. Okay, now the in bit one, see that type of questions will come in the assignment, right? It is easy to see. Why I'm going to say this is a numerical area, you have to do the calculation at any cost. Okay, so when this assignment is coming, but on the basis of that type of questions may arises in the examinations and in your professional life also. It will come down, that is, there is a question in bit I, MCH-4. I am telling you, MCH-4 assignment bit I. A copper electrode emerged in 0.22 m. M means molarity, means concentration of copper nitrate solutions. Okay, CuNO3 whole 2 solutions. If you go to that area, so that can you say anyone who can exactly? Yesterday I have done that one, but I have not put the value of electrode potential. So last when I finished my class, I just asked you all that, and one Divendu, maybe that student Divendu was just asked the question, sir, is it essential to memorize all the standard potential value? I told yes, but okay, in for the examination it is yes. Why? Because you will not get any from any source that electrode potential value, but in the practical life when you are doing that, this is a fixed value, you can access from any source, right? But thing is that when the copper matter is there, the electrode potential value, as I said yesterday, so electrode potential, standard electrode potential value of copper is plus 0.34 volt, right? So and also that yesterday I have done one numerical. So all of you have gone through that one. Do you understand that numerical, or shall I start with this numerical again today? If anyone can share that whether do you understand that what whiteboard I have used yesterday? Okay, that okay,
Understood. Understood.
okay.
Please
Yes,
start
yes,
in
has.
numerical.
Okay, thank you, Soman. That I'll do that one. Okay, for your better understand that I'll start with the numerical. Okay, let me
Okay,
to
sir.
do.
Okay.
Yeah, thank you, thank you. That is, so let me to go through that. Try to understand these things, because if you use that thing, you will do the actually you will do the answer of the questions in the examination. Now all this also in the practical life of your that is thing. Okay, let me to go to the my whiteboard. Okay. All of you see the question, right? Uh, uh, are you getting my voice? Are you getting my voice?
Yes,
Sir,
sir.
yes.
Okay, okay. That's. Can you see the whiteboard right now? My whiteboard. Tell me yes or no.
No, sir.
Okay, just let me share the whiteboard. Can you see, able to see my whiteboard right now?
No, sir.
What is happening? Okay, just a second. Let me do that. Just okay. It might be the problem over there. Are you able to see the whiteboard right now?
No.
Just a second. Is it fine?
No, sir.
What happened? Just a second, please. Just a second. Just let me to try again. Can you see right now?
No, sir.
What is happening right now? Okay. Just a second. Can you see right now?
No, sir.
No. Yes, no.
No, sir. No, sir.
What is happening? Is it fine? Are you able to see?
No, sir. No, sir.
Just let me to disconnect again. I have to connect with you. Okay. Just be on line, all of you. Are you able to see?
No, sir.
Okay, that's some issues are there. Okay, no problem. Okay, if you have pen and paper, just open it. If you have, if you don't have, so that is not the issue. But I can say the things, then you can understand also, because if my whiteboard is not, I unable to share with you. Can you have your pen and pen and paper with you?
Yes.
Okay. So now the question is, if you have seen that question, that is in the a copper electrode emerged in 0.022 m. M means molarity. I told you molarity means concentration. So don't be confused about that one. What is the strength of that solution? That is 0.022 molarity of a copper nitrate, NO3 whole 2. Okay. So here the electrode is copper. Okay, we have to put the formula, that is your Nast equation formula. Only one electrode is given here, because you know that I told you in the galvanic cell, if you understand, two electrodes will be there. One is zinc is there and another is copper is there, right? One acts as an anode, second acts as an cathode, right? So copper acts as, and also I told you so yesterday that the electrode which accept electron, that is known as the cathode, and it will be the denominator part, not numerator part, means reduction half, right? And the electrode which is that donates electron, that will act as an oxidation half, that is oxidized electron, or you can say it is an anode, anode. Okay, now as you see here, the solution is CuNO3 whole 2. Okay, Cu copper nitrate, CuNO3 whole 2. So whole 2 means here copper will be 2 plus, because nitrate is in the anionic state and copper is the metal, that will be the cationic state. Cationic state means it will donate electron. So whole 2 means NO3 is a single oxidation is -1 NO3, as 2 NO3 is there, NO3 whole 2. So oxidation state will be -2 of NO3 nitrate, as well as so copper will be +2. So now the state of copper is Cu +2 in this solution. Okay, so what you have to write down? You have to write down CuNO3 whole 2. Write down right now. Those have pen and paper, what I'm telling you, just write down. CuNO3 whole 2 copper nitrate, then gives rise to arrow mark, give rise to Cu2 plus NO3, 2NO3 minus, 2NO3 single minus. Write down this equation. This is the ionic equation. This is the now the in aqueous solution, copper nitrate will behave like this: Cu2 plus NO2NO3 minus. Okay. Now what happened? The state of copper? Copper is in deficiency of electron, 2 electrons in the aqueous solution, as copper donated 2 electrons. So copper is in Cu2 plus state, right? So that means copper in deficient state, it should accept the electron to become the, means what is to come down the neutral condition. So copper will accept the electron. What exactly yesterday I explained that things. So now in the second reaction, write down Cu2 plus, 2 plus will be in the upper part, right? Cu2 plus,
सर
yes,
हेलो
yes, Somen.
सर आप जो सेंड किया ना जैम बोर्ड सर एक्चुअली मोबाइल में जैम बोर्ड फाइल डाउनलोड करना पड़ेगा
I am not using mobile, sir. I am using that my laptop, right?
ना ना सर हम लोग तो मोबाइल यूज कर रहे हैं वो सर जैम बोर्ड डाउनलोड करना पड़ेगा उसके बाद व्हाइट बोर्ड आप मिलेगा
Okay, then what to do?
सर आप व्हाइट बोर्ड में कुछ लिखिए उसके बाद में सब शायद मिल जाएगा
तो
व्हाइट बोर्ड में
अच्छा वो मैं देख रहा हूँ, एक
हाँ।
सेकंड में ट्राई करता हूँ दोबारा।
हाँ सर व्हाइट बोर्ड में आप कुछ लिखिए।
हाँ मैं व्हाइट बोर्ड को पहले शेयर करता हूँ, उसके बाद में लिखता हूँ, ठीक है? जस्ट अ सेकंड प्लीज। Is it visible right now?
visible?
No visible. No visible.
Is it visible?
Sir, no
Now-
visible.
Okay, you are not visible, na? It is not
Yes.
visible, right? Okay.
Yes,
It
yes.
is
So
visible.
that
sir,
means
please start writing.
I wrote something, sir.
Yes,
I just wrote hello CO2 plus something. I wrote that. So yesterday it was actually some problem maybe there.
Yes, sir, visible.
Okay, all of you visible my white screen. Then I can write.
yes,
No,
visible.
sir, visible.
Okay, that's fine. That's good. Okay, let me change. So you all of you there. So just let me go to the another page. Okay. Okay. Now, so here we have that is the scenario is like this. CuNO3 whole 2. This is the aqueous solution. Okay. This is the your copper nitrate is given. Okay. It will come down CuNO3 whole 2, and in aqueous solution, what will the behavior of this one? CuNO3 whole 2 gives rise to Cu2 plus 2 NO3 minus. Okay, 2 NO3 minus. Is it visible?
Yes, sir.
Okay, take the screenshot of this one. This is the first line you have to write. Okay, then I'll go to the next part. Now the thing is that now you see here copper nitrate now gives rise to the aqueous solution. Copper nitrate gives rise to, here you can write AQ also, aqueous, okay, as concentration is given aqueous solution. So copper nitrate will convert into two parts, that ionic part, one is cationic part, Cu2 plus, and NO3 minus 2. 2 NO3 minus 2 part is there, right? NO3 whole 2 is given, 2 parts are there. So that is NO3 minus. Okay. As we are thinking about the metal, okay, so we have to think about the copper only. Okay, now what is the state of copper in aqueous solution? Copper is 2 plus state. Now the copper is in the 2 plus state, right? So means cationic state. Then what does it mean? Copper lost its 2 electrons. So then what to do? As copper lost 2 electrons, it needs 2 electrons to be for the neutral condition. Then Cu2 plus 2 electron gives rise to Cu0. Means copper already lost 2 electrons. Now copper got 2 electrons. Now the state is 0. Okay. So that means what happened? Just link it. Yesterday we are discussing N plus any electron, then M0. That is oxidation state. As you see, copper is accepting 2 electrons to get its neutral state, means it is gain of electrons, means acceptance of electrons. If anyone accepts 8 electrons, its behavior will be reducing. Its behavior will be reducing. So reducing behavior means it acts as the cathode. Got the point? If anyone is accepting electron to become neutral, then what will happen? Its behavior will be what? That is, its behavior is accepting electrons. So it's be accepting electrons, hence it will be reducing in nature. Reducing means it will behave as the cathode. Means reduction. Okay, reduction. Not reducing, that reduction part. Okay, so this is present in the reduction half. Means galvanic cell, one is left hand side will be oxidation half, E cathode and E anode, E right, E left. If you see, if you that focus on that formula. So yesterday I told you E right minus E left. That means E cell is equal to E right minus E left. Also I told you right and left is not, actually we are not considering right and left, but it is okay, no problem. We can write down E cathode minus E anode. So where is the cathode? Reduction part is the cathode. Where is the anode? But that is oxidation part is the anode. Now the thing is that here copper accepting electrons. So that means it is reduction. Reduction will be in the denominator part. Then next part, what will happen? See. Now what is given? This is completely reduction. This is reduction. reduction. Okay, this is reduction. Reduction means it is your what is that? Cathode. It behaves as cathode. Got the point? It is the cathode. It is the cathode area or cathode part. Anyone has doubt regarding this? How we find out why we got this cathode or anode? Anyone has doubt? This is cathode because copper accepting electrons right now. It is cathode. Got the point? Okay. Next thing is that if you go to the question again, now the concentration is given, molarity. So this is the concentration. So concentration of a cathode is what to write down next? Concentration of a cathode. Concentration, that is your molarity, is equal to 0.022 m. 0.022 m. It is given concentration. Okay. Now, so what is the N? N factor is N is essential. If you go to your whiteboard, you see how many electrons it is accepting? 2 electrons. So that is your N value. N is equal to 2 here. N is equal to 2. Right? N is equal to 2 here. Got the point? So you got N value. You got what is the concentration value. Now we have another thing. That question was connected yesterday. Whether we want the electrode potential value, that means standard electrode potential value. Yes, I told you yes. Without knowing the standard, if 2, 3 that is variable will be there. So that means you need to find out the value of one variable, at least directly or indirectly. You should know that except one, you should know all the variables, value of all the variables. So here many variables are there because you will go to the when oxidation, that is the formula. So yes, electrode potential value is essential. So as it is copper here, the electrode potential value is inert cell value is equal to your 0.34 volt. Yesterday we have discussed this about this one. Okay, so now you got the electrode potential value, you got the concentration, you got the N, then we have to find out. So now the formula is E cell is equal to inert cell minus 0.0591 or 92, whatever, maybe 91 divided by N, then log 1 by concentration, reduction or concentration. This is the reduction value or concentration value. This is the formula. From where we got this formula? We got this formula from the Nernst equation. Right? Now we got this formula. Again, we'll go to the, we'll put the value of this one. E inert cell value is 0.43. Sorry, 34. Sorry, this is 34. 34 or 43? What is the value of that one? Copper. Again, I forgot that one. Just a second, please.
34.3.
Okay, 0.34, right. So we are right. 34 volt. Okay, I put the value of inert cell minus 0.34 volt, then minus 0.0591 divided, what is the value of N? 2. Already we have wrote there. Then log 1 by, what is the reduction concentration? Reduction concentration value, you know that, what is that? 0.022 m. Okay, so this will be 0.022. Okay, so this is the value equation you got. So you have to calculate this one and you will find out the value of E cell. You have to calculate. You have to calculate this thing, so you can find out the value of that as E cell. What is the E cell value? Got the point?
Point 0.0490.
Okay, no problem. So, may not be you have the mobile phone or that is calculator in your examination. So, okay, no problem. That's good. But you have that is fine. No, it's a you have calculated that one. That is good. Very good. So, do you understand? Anyone has doubt to find out how to sort it out these things? This question. All of you understand how to sort it out this question, or anyone has any doubt? Still, if you have any doubt, you can ask me, because see that after this, so many things will come across. I'm just a very simple process we are following right now, and after
Sir.
this, yes, Soman.
Sir, use study material using E0 plus sign. After E0 plus 0.591 by 2. They are using log concentration of M. 1 by M नहीं कर रहा है.
1 by M means what? Do you know that M means metal, right?
No, I am not saying that. I am saying that they are using positive.
No. Actually, the thing is that see, that is not the positive. Okay, yesterday I told you, na, that is actually Nost equation. See, that a value will come in the positive. It will never will come in the negative, because it is E cell value. So that's why their sign they are changing, right? They are changing the sign to get the value of that one. But see that when as it is the if it will come in negative, see, volt will be never be negative, right? Can we say minus 20 volt?
No, sir.
No. So that's why, as it is single value is we are using only one electrode, we are using only one electrode, that is copper. So that is the only reduction part. We are not using both the electrode. Here we are using a single electrode. So that's why they are putting their plus sign to not to make the confusion, right? But actually that Nost equation is not like that. Nost equation is negative. Yes, absolutely. Because we are putting the value of Nost equation. We are putting the value in the Nost equation, right?
Okay.
So to understand these things, try to understand. So see, when we are taking the classes, lots of things are coming to that students are a little bit it is a very good question, Somen, because if you understand the because I am going beyond a chapter right now, what I was going to say, thermodynamics. Okay, if you go through the thermodynamics, so in chemistry, thermodynamics, we teach the same formula in the negative by using negative sign. But in physics, same formula in thermodynamics that they're using positive charge. Because because in physics there is no reverse things. Okay, but in chemistry, system to that environment to system energy transformation is there. So that way plus and minus may be used. So it is your you have to understand whether it is thing is that if the answer will come very clearly, I am telling you, if your answer will come in the negative state, right, negative sign, any volt, any current should not be in the negative sign. It cannot carry the negative sign. If you come in the negative sign, then you just make it plus. Okay, that is simple facts you have to use. But formula is not in negative state. If I say two formula, one negative, one positive, now you have the questions. Why you should have the questions? Because there is a confusion. When you read through this, your syllabus books, you will actually you will be confused. Here is minus, there is a plus. Actually, not like that. So that's why you someone may ask the questions, right?
Yes, sir.
Yeah. So don't be confused. Very clear. My lecture is very, see that I am very much straightforward and clear, right, in this case. So Nost equation is in negative. Okay. E cell is equal to E naught cell minus. Okay. Not plus. But as we are putting only one electrode, so value may be that E cell value may be negative. Maybe. So, but if both the electrode value will put down, it will never will come in the negative state. It will come in the positive state.
Yes, sir.
So thousands, crores of problems we have done in our when you are studying and teaching in the daily life, we are doing 1,000 crores of problems over this, right? But thing is that we are not facing any kind of issues because both the electrode we are using. If single electrode, very straightly, very honestly, if single electrode is given like a copper or single, second example is zinc. Your question second example containing zinc. So zinc will be in the oxidation half. Because zinc will lose the electron, right? Zinc will lose the electron. If it will lose the electron, means loss of electron means oxidation. So it will be in anode part. Anode part will be means upper part. I told you yesterday. Now for the copper, formula is 1 by CO2 plus, concentration of CO2 plus. For the second question, the formula will be log zinc concentration of zinc, not 1 by, because it is the oxidation half. Got the point? So in that case, if you see, in that case, that the answer will not minus. So if the minus will come, if your answer will come in minus, so you have to put the one statement. So that as volt is always positive, so sign of this value will be changed into positive, and the answer will be this. That much, nothing else. No need to write. We'll evaluate the things. We know, we understand. Okay.
Sir,
Yes.
in the case of zinc,
Yeah.
We are using E0 value is minus 0.763 volt.
Sorry, in case of zinc, minus 0. Minus, yes, absolutely. That is the electrode potential value of zinc, minus 0.76. That's why I told you. See, here is minus, there is minus. Then multiplication will be gives the plus. Got the point? So that value will never come. That's why I raised that thing. That's why when oxidation or anode part you are using, that value will never be in minus. Never be. It will be always give the plus, because that part will be the negative sign. It carries the negative sign itself, because it acts as the value will decreases. Got the point? So minus that minus value and this minus value will multiply and give the plus value. So that's why don't worry for that one. That will give only oxidation half is given. So that will give you always the value will be cell value is the positive. But if the reduction value is given like copper, so maybe minus will come. That's why it will not minus. So you have to put the plus, right? That is the difference between. It's a technical issue, mathematical technical issue, mathematical error. Okay. So hope. Thing is that okay, so I like that you have to do the zinc case also. One question is there also, zinc, for that zinc you have to do that one also. Okay, now I'll just okay, now I'll share your topic. Okay, so we understood these things yesterday, and regarding that question and all the things. Here it is given the minus in the formula, right? If, can you able to see my sharing the screen? Somen? Hello?
Yes,
So,
we can see.
yes,
We can see.
that is it. Yes, thank you. So E cell is equal to E naught cell minus 0.0591 by n log 1 by m n plus, right? Here the minus is in the formula. Got the point? So no need to worry about that. The value always will be the plus. Technical things you have to only think about this, that whether it is plus or minus. Okay. Now I'll go to one actually that before sharing these things, let me to share one that slide. Okay, just a second, please. Just a second, please. Now we have to understand this thing first. That is, yesterday we have discussed about that how the electroanalytical methods are. This means in the But it's a chain and all the things you have discussed already. This is from your syllabus only. Okay. Now the potentiometry, this is the part of the discussion. First we have to understand this, and then I'll go overlook with your, that is your syllabus. Measures potential under very low currents. Okay, that is the most important area of that is fact is this that why potentiometry is so important, why we are studying these things, what is the main issue. Okay, so it is the first is it is measure potentials, means electrode potential value can be measured under very low currents. Means you will use the battery, no need to use any kind of electrical current or any kind of AC current, right? You can use the battery, and on that you can use measure this potential of these things like voltmeter, ammeter, like this. These are the potentiometry. The cell is 2 half cells. This potentiometry is 2 half cells, consist of a reference electrode that I told you, reference electrode, and second is indicator electrode, third is potential measuring breeze or a device, you can say. This potentiometry has 3 things. One is three things. It is consisting of 3 things. One is that a reference electrode, second is indicator electrode, third is potential measuring device. So reference electrode, you can use REF for the abbreviation form. For the salt-free means your what is that measure, that is the indicator electrode, we can use EIND, and salt-free is also EJ, you can use also for that one, EJ salt-free. Okay. Now reference electrode, what do you mean by reference electrode? An electrode with a known constant half potential. Okay. If you are if you are using that any electrode whose potential value is known, you know that, like this, we are finding out the electrode potential of something by using another one. Because if you know the electrode potential, like copper, you know that a 0.34 volt of electrode potential, it will be a reference electrode. So another electrode we can refer to this one, that is indicator. That another one is indicator which has to find out. So this is and intensive of composition of the solutions. Okay. Now ideal reference, reversible, obey, Nost equations. Okay. So what is the reference means if reference electrode you are using, what kind of electrode will be the reference electrode? Reversible and obeys Nost equation. It should be. Exhibit stable potential over time, means constant or stable potential it will give for a longer period of time. Returns to original potential in presence of small currents. Not sensitive to temperature changes. These should be that we can say that a particular electrode is reference electrode if that electrode will follow these points. It obeys these points, then you can say it will be a reference electrode. Next. Then in the potentiometry, the potential of reference electrode in aqueous solution. See that it is actually that thing is that so many things are there. Standard that put electrode potential versus standard hydrogen electrode potential in volt. So that is one table we have provided you. That is here. If you compare with the silver chloride, silver with silver chloride, then this type of a value will become, and you will go to across this one later. Okay. Then potentiometry, reference electrode. What kind of a reference electrode? One that calomel electrodes. Standard calomel electrode SC consists of mercury in contact with the solution of calomel and KCl. Calomel KCl solution, which one that is given under the below. That means mercury / mercury chloride saturated, then KCl and concentration of a KCl. Okay, that is concentration. This particular thing is known as calomel of KCl. Okay, then KCl usually 0.01 or M molarity. You can use potassium chloride under the very specific molarity means concentration 0.01 or 1m, and 4.6. Three things you can use the concentration: 0.01 or 1 or 4.6 saturated standard calomel electrode. Okay. Standard calomel electrode most commonly used as the reference electrode. So usually standard calomel electrode is used as the most common electrode. Okay, most common that is reference electrode. And advantage. What is the advantage of this one? Easy to prepare. What is the disadvantage of this one? Sensitive to temperature changes. If you will not control the temperature, the behavior will be changes. So standard electrode, standard calomel electrode potential is 0.244 volt at 25 degrees Celsius. You have to memorize these things. Okay, these things is fixed things. Okay, 0.244 volt at 25 degrees Celsius. When you do in the further time being, you will do the numericals, calculation, and all the things, and the practical use. See, these are actually, I am telling the potentiometry, the maximum use in the pharmaceutical industries. Maximum. Most of the cases that pharmaceutical industries use this potentiometry. Okay. Now we'll come to down. This is calomel electrode. You see the picture. This is the calomel electrode. So you have to understand, right, how it looks like calomel electrode. Okay. Next. Potentiometry, then a reference electrode. Another thing is silver, then silver chloride electrodes. Silver and silver chloride electrodes. Silver where in the solution of KCl or AgCl. You have to take the KCl or potassium chloride or silver chloride in the test tube or something else. So, and also in the container, and you'll put the silverware into it. Silver and silver chloride saturated, KCl saturated. These are the things. So here silver chloride and electron will accept, it will be belongs to the silver plus 2Cl minus. This is the representative equation, because you know that AgCl gives rise to Ag plus and Cl minus. When Ag plus will be there, it needs another electron to be the reduction. It will be there. So in the reduction part, and 2Cl minus. So E naught Ag and AgCl value is 0.199 volt at 25 degrees Celsius. This value should be memorized. The reference electrode. Next, see, this is the thing of what is your reference electrode. Reference electrode for AgCl, right? Okay. Now next, if you go to that point, then potentiometry, indicator electrodes. An electrode system having a potential that varies is known in a known way with variation in the concentration of an analyte. Then indicator electrode. What is the indicator electrode? An electrode system having a potential that varies in a known way with variation in the concentration of analyte. Then formula, how could this one? E cell is equal to E indicator minus E reference plus salt freeze. Means your that is salt freeze, value of salt freeze. Okay. Then ideal indicator electrode. What are the ideal indicator electrode? Response quickly to concentration change of an analytes. Gives reproducible results. So these are the behavior of indicator electrodes. Then indicator electrodes may be three types. One is metallic, second is membrane, third is ion selective. I just want to share one of my experience that we were working on that is water purifier. That is, you know that in the water purifier usually the candles are used, right? And time to time, whatever may be the brand and all the things, water purifier, the candle should be there. Okay. But we are working on that is the candles are there. Actually, what is the job of a water purifier? It's a hard water to soft water, right? Water purifier you are using at your home, that is only hard water to soft water. Am I right or not?
Yes, sir.
Yes. Only hard water to soft water. We will convert only hard water to soft water. But salt water, you know that if you move to the that is UAE, you'll see so many that water harvesting plants. I know that some of the peoples are working over there in the that is UAE. Out of maybe you, the peoples are. Mr. Kedar was there. Sometimes Mr. Kedar, you are there, and sometimes in the UAE, or are you there still in the UAE?
I'm in Saudi Arabia.
Okay, Saudi Arabia. Okay, that's fine. So can you say that what is the means? See, it is. I have never been to the Saudi Arabia. So what type of water? How the water means? Drinking water you are getting?
What is that? That is a purified water. That is sewerage water, sea water to salt water to.
Absolutely. That's my point. So have you ever visited to that any saltwater plants?
Yes.
Okay, that see that what is the means? Okay, we are getting the means purified water. Those
Yes.
who are sir, just Kedar sir, just a second, please.
Okay.
Please, this is an interesting fact. All of you had to listen these things because that man having some experience, that physical experience, but I do have experimental experience. So that's I remembered in the first class that Mr. That Kedar was telling that he was in somewhat in. That is that country. So that's why I just memorized that thing. I asked because I do have an experimental experience what we are doing and working on that one. So but okay, so that's why you people have to understand the things what is actually why this kind of things I just asked, because here is one is their membrane, right? Three types of indicator electrodes are there. One is metallic, second is membrane, third is iron selective. These three things are used in your water purifier system, right? All three things. I'll tell you how. So now we'll listen to the Mr. Kedar that if you visit over there in that water purifier that is plant, so what hazardous things will be released from that particular plants? We are getting no problem. Seawater too, that is fresh water, we are drinking that one. But when the process is there is a hazardous things is there. Right, Mr. Kedar, are you there?
Yes. Yes.
Okay, so have you ever visited to that plant, water purifier plant?
Yes. One time
Okay.
I visited the plant.
Okay, that's fine. So do you have any idea that any kind of hazardous things is released or not? Do you have any idea?
Some sea water, there is a hazardous material is there.
Correct. Okay,
Some
that's fine.
that will be separated through the.
That is
some,
not the
this
issue.
one.
That is not the issue. Okay, that is not the issue. We have to settle down that one. That hazardous matter should be settled. It will come down.
Settled on the bottom.
Yes, absolutely. It will come to the surface area of the soil or something else. So it will create nasty things. Okay. So that what I'm going to say. We people, a team of people who are working on one things. We are preparing one acetone layer, right? And now I'll connect to that at your what is that water purifier candle. That is what is used for the purification of water in your water purifier. We are preparing one a team of member. We are preparing one membrane, that acetone membrane. That is a organic process, right? It's a long process, research level and all the things. So if we put the salt water into that membrane, then what will do? You know what will happen? So only that fresh water will be come down, and that remaining part will be there. No other process. Simple. We can use this one in your your water purifier. But thing is that is more costlier. That preparation of membrane is not it's easy one. It's more costlier. And see, we the people of India, we are getting the sufficient of that is fresh water. So right now, time will come. So we have to use that one. Okay. So thing is that It is the essential part of the chemistry. Okay. Now the thing is that indicator electrode 3 types. That is one in metallic, second is membrane, third is ion selective. Okay. If you go to this indicator electrode, that is metallic indicator electrode. So what is that? Electrode of the first kind. It is the electrode of the first kind. It is not research level, first kind. Pure metal electrodes in direct. We use the pure metal electrodes, equilibrium with its cations in solution. So that means like that, copper sulfate, you will dip the copper electrode into the copper sulfate solutions like that. So it is given here that Cu/Cu2 plus or Ag3 plus. Like so, this is the pure indicator in the state. Okay. Second is indicator is metallic indicator. Continue with this is the first indicator, pure metal electrode in direct, equilibrium with its cation in the solution. See now the Nernst equation is there, right? Below that, E indicator, that is E cell. E indicator is equal to E naught x to the power n, which is metal electrode we are using, minus 0.0592 by n log 1 by x to the power n. Okay, this is the simple process. How will potential you will calculate it? Okay, you will understand these things once. Everywhere there will be Nernst equation, because first you will see that you have to every that will be electrode which follow the Nernst equations. It follows the Nernst equation, then we can use it. Then disadvantage. What is the disadvantage with the metallic electrode? So not very selective. It is not actually it is not useful for everyone, right? May respond to several cations, right? So may respond to several cations. That's why it is not selective one. I need some specific one. Suppose I have to extract the copper from something else. I cannot use it. It may that is ore content copper, maybe zinc, maybe silver, maybe any other things. So it may attract so many things. So that's why metal may dissolve in acids. So as you know that metal is corrosive in nature and it will react with the acids. So then it may be metal may oxidized. That's why it is not useful. Useful in means it is useful, but it's not selectively you cannot use. Okay. Now that it will come down Ag/Ag plus, Ag silver and Hg mercury and mercury plus used in neutral solutions. Right? It is used in neutral solution. Copper 2 plus, zinc 2 plus, cadmium 2 plus, bismuth 2 plus, titanium 2 plus, lead 2 plus must be used in the deaerated solutions, not aerated solution, deaerated solutions. Next, so electrode of second kind, metallic electrode of second kind, second type. Okay, metal in contact with an anion that form precipitate or complex with cations. So this is AgCl. So here Ag and AgCl is the Cl is the anionic part, Ag is the cationic part. So it will gives the electrode potential 0.222 volt. Okay, it will follow the Nernst equation, and Nernst equation is there. Okay, now the electrode of third types, metal electrode. So it is actually now it is going on. So that is third type. So electrode of the third kind, metal in contact with a solution that responds to a different cations. So different cations like your mercury electrode to measure potential of calcium, right? Potential strength of calcium. So metallic indicator electrodes, indicator type of electrode. So now metallic electrodes we have 3 types: kind 1, kind 2, kind 3. So this is over. Now indicator electrode. Okay. So just a second. Okay. Then indicator electrode, metal electrode as indicator, right? So okay, right. Indicator electrode, metal indicator as electrode. Okay, metal as indicator electrode. So it is the third kind, metal in contact with solution that responds to a different cations. So that here is a mercury electrode to measure the potential of calcium. Indicator electrodes. Now metallic indicator electrodes, redox system, platinum, palladium, gold, carbon in contact with a redox system. So platinum in selenium 3 plus to selenium 4 plus. So here electrode indicator is equal to E inert cell of selenium 4 plus, then this value of, see here is the oxidation half and a reduction half. So one is 4 plus, second is 3 plus. 3 plus means it will lost 3 electrons, now it is 4 electrons. Okay, so that is why. Next, now we'll come to the membrane indicator electrodes, that is metallic electrodes over. Now we'll come down the membrane indicator electrodes. Okay, just a second please. Okay. Now the membrane indicator electrodes, membrane electrode also called ion selective electrodes. This ion selective electrode, see that I told you now that it will select some that is acetone base, that is membrane selected ions, means what type of things are there in seawater. So that will be selected by this and it will be extracted. Okay, that is the main concept of this one. So crystalline membrane electrode, see, next polycrystalline or mixed crystals. Third is non-crystalline membrane electrodes. So under the crystalline membrane electrodes, one is single crystal. Example, lanthanum fluoride, trifluoride. For fluorine minus, it will be lanthanum is a group D of that is elements. Okay, that is fifth series elements. For fluorine minus, it will selectively use for the fluorine. Polycrystalline or mixed crystals, example Ag2S silver sulfide, so it is used only for the sulfide and silver. So this is specific, right? Then non-crystalline membrane electrode, it is specific, that's why selective electrode it is called. Non-crystalline membrane electrode, the glass, example silicate glasses for sodium and hydrogen, glass is used as a membrane. Liquid, examples liquid ions exchanger for calcium 2 plus, calcium 2 plus, and neutral carriers for potassium plus, liquid also used. Immobilized liquid in a rigid polymers like PVC matrix for calcium 2 plus and a nitrate minus. So these are the selective. Okay, now indicator electrodes as the membrane indicator membrane electrode as used as the indicator electrode. Properties: minimal solubility in analyte solution approaches 0, that's why. Electrical conductivity must be small, usually in the form of migration of single charged ions within the membrane. Third, selective reactivity must selectively bond with analytes ion by ion exchange, crystallization, or complexons. Okay, these are the actually the properties of membrane electrodes that is used as the indicator electrodes. Okay, next, indicator electrodes, membrane electrodes, that electrodes which is used as the that is indicator electrodes again. So ion electrodes, so pH electrode, glass electrodes, no electron transported across the membrane. This is the simple things, no electron transported. So membrane allows certain ions to cross while excluding others. Membrane allows certain ions to cross the while the excluding others. So that is happened in case of this. Next, membrane electrode. So pH electrode as a glass electrode respond to the change in pH, consists of sensing that electrodes, reference electrodes, half cell system. Nowadays use the combination of electrodes as sensing electrodes and the build up the reference electrodes, both. Okay, now this is the pH electrode. You see that a pH electrode contains, now go through this diagram and this level of this one. Let me do just increase the size of this one. Okay, now check it out, where is A, B, C, D is written, and I check it out. So just go through this diagram once, then I'll go to that. Okay. So that is pH electrode. So these are the diagram will come and all the things. Now indicator electrodes, membrane electrode as the indicator electrodes. So it is around the pH electrode, glass electrode, the sensing electrode is measuring pH across this thin glass membrane, 0.03 to 100 mm thick glass electrode consisting of 20% Na2O, okay, then 6% of calcium oxide, sodium oxide, calcium oxide, then 72% of silicate SiO2, or 10% of lithium oxide, 10% of calcium oxide, and 80% of silicate or SiO2 for the Na plus errors, right? So these things will be used in this membrane electron. That is these the things. pH electrode at the glass electrode. So that thing is there. Okay. Next will come down. So pH measurement occurs by an ion exchange reaction. So H plus solution, Na plus glass electrode. So Na plus H plus glass electrode is there, right? And the pH membrane electrode, hydronium ion partially. See, this is the scenario. Hydronium ion partially, when you put water, right, in acid, so hydronium ion will form. So partially postulates both the inner and outer of SiO2 surface. See how it is bonded. Okay, the concentration difference results in a potential that across the glass membrane. This is the scenario. Okay, a special glass is used. 22% of Na2O, 6% calcium oxide, 70% SiO2. These things, when this potential difference will be created, okay, then this will be happen. Next, indicator electrode. Again, membrane electrode as the indicator electrode. Membrane electrode can also be used to measure other ions. First type, that is were used as sodium plus, calcium 2 plus, and chlorine minus. Sodium plus selective glass electrode made up with the. This is the glass electrode. What glass electrode used for which one? That is specific. That composition is given over here. 11% of sodium oxide, 18% of aluminum oxide, and 71% of silicon oxide. Okay, this is intent of instead of the glass of membrane may be polymer saturated with a liquid ion exchanger. You can use also ion selective electrodes. Okay, then many ion selective electrodes are membrane based device which separate the sample from the inside of the electrodes on the inside of the filling the solution containing of the filling of solutions containing in the ion of the interest at the constant activity. Okay, this is the calcium ion selectivity electrode examples. It is given here. Ca2 plus ions. See in the there is a that is thermometer type where silver and silver chloride reference electrode is used. Then yellow type is there, ion exchange reservoir is there, and there is a green type porous membrane is there, and there is a voltage sensing area is there. Right? Internal reference electrode is used. So this is the liquid membrane electrodes. Okay. Now if you come down to calcium ion selective electrode methods, liquid membrane electrons. See this is the things how the calcium ion that's the reservoir from this calcium that the ion will be separated. The reservoir forces exchanger into the membrane. The exchanger forms complexes with the species of interest. The result in a concentration difference and resulting change in volt that we can measure. So this is the difference how it will be happens. Okay. Now again that membrane electrode uses indicator electrode. A gradient is established across the membrane when the electrode is immersed in a solution. So del G is equal to minus RT ln A sample by A that is indicated about you can aqueous solution. You can say that R is value is your minus 8.134. You have to memorize this value. Joule per K mole inverse. Joule per K, joule K inverse mole inverse. K means your Kelvin temperature. Potential produced E is equal to minus del G by NF is equal to RT by NF ln A sample by that is your solution. Okay. So now the thing is that indicator electrode membrane potential is this. This is the formula. This potential is monitored relative to the reference electrode. Then you can reference electrode. You can check if the value is that what type of value it will provide with the reference value. Then membrane electrode as the indicator like E is equal to K plus, this is the another formula also, 2.303 RT, this is ln value, RT by Z in indicator electrode, fluorine ZF, and that is also salt bridge, log salt bridge, where Zi is the ionic charge, Ai is the ionic activity, K is the constant value. Okay, that is these are the value of this one. So if membrane electrode again E is the proportional to the log Ai, so 59.1 mole volt of means mass volt, you can say, change correspond to the 10-fold change in a that is for monoatomic ions. So Ai unit dilute solution, this is the, you have to take the reference as this one. So these are the value of this one, a major inference, that is range of concentration, ammonium ion, what is the range of concentration in the which reference electrode you are using, potentiometry, in that case you have to use the value. So solid state electrode. So and third type of electrode is membrane, then is solid state electrode. Eventually membrane electrode, that is lead to solid state electrode. So you are using the that is not lead, it's a lead to the reference electrode. Okay, so crystal electrode examples: fluoride ion selective electrodes consist of lanthanum fluoride crystals, fluoride ion selective. Internal electrolyte solutions, that is your concentration will be like this, 0.1 molarity NaF and 0.1 molarity KCl. You have to use this one, then this will be happen. Okay, solid electrode, crystal electrodes example: fluoride ion selective electrodes. This is the LaF3 crystal is dropped with the euphorium F2 to provide the that vacancies holes of the fluorine ion site. So it will creates a holes. So fluorine will be attracted by that one. That is so NOST response to the, it's often down into 10 to the minus 6 molarity. So E is equal to K minus 0.0 log AF. So interference indicator electrode solid phase. So ISFET ion selective field effect transistor. Coat a transistor with the chemically sensitivity material, analyte it contact with the material and a reference electrode. Change in analyte concentration give change in electrode potential. Advantage: rocked, small, inert, rapid response. Disadvantage: most of the reference electrode. Okay, so this is the thing. So you can use this. This is the thing that reference electrode is there. So how the things will be work out in this case. Okay. So this is the area that we have prepared for this one slide. Let's go to your syllabus. Okay, now the potentiometry, that potential, that is two things are there. So potential measurement with the potentiometry can be done by two things. One is direct, second is reference. So here is the first one is the that is your direct method. Okay, direct potentiometry. How can directly you can use this one? See, that is in the direct potentiometry, it is a method which makes use of the single measured electrode potential to determine the activity of the ion interest. Okay, so that means only single electrode, like your copper or zinc, only one electrode you have to use, and you have to calculate that is how does it behave, and which ion you have for your interest. Suppose you have to work for the any kind of ion, so on the basis of that you have to use direct look, that is thing. This method is widely used for the determination of pH of the solution using hydrogen electrode. So hydrogen electrode, standard hydrogen electrode, it is actually platinum which is that is wrapped with the platinum, and in that hydrogen gas will be platinum wire will get that wrapping with that platinum wire and input inside that your container. So it will provide the hydrogen gas. On the basis of that will be calculated. Okay. So determinants of other ions using different ion selective electrodes. In all the electroanalytical method, 2 electrodes are required. I told you that is one oxidation, second is one oxidation half or anode, second is cathode. So in all that electroanalytical method, 2 electrodes are required. The potential of one of the electrode is known. It should be. If you don't know the potential, that difference of that one, so you cannot calculate it. No, constant and completely independent of the composition of the solution. So this electrode known as the reference electrode. So reference electrode we have already discussed, which the value we have to take as the reference, right? On the basis of that, you have to calculate. So E cell is equal to E indicator minus E reference plus EJ. EJ means salt bridge reference code. Okay, that value will put down. So you will find out the value of that. Okay, so E indicator is equal to E naught indicator, and I told you in that also PPT. So E indicator is equal to E naught indicator plus 0.05 G. Plus is given as this is value will be negative, or so negative value should not be calculated. So that's why plus will be given here, as earlier we had discussed. Okay, now this is the okay. We will come to the reference electrode. So what is the main potential, more important things of this reference electrode? The potential of the electrode should remain constant even some current is passed through it. Okay, so reference, which will be the reference electrode? That reference electrode means if the current will pass through it, that one we have given the what is the condition for that one already in the in the PPT. But here that is the potential of the electrode should remain constant even some current is passed through it. There will no changes. That will be can consider as the reference electrode. The potential should be reproducible. Okay, the electrode should be easily prepared from the easily available materials. The potential of the electrode should not change with temperature. It should be shift. Right. These are the things for the that is reference electrode. So on the basis of that, we have first electrode is hydrogen electrode. Hydrogen electrode can be used as the reference electrode more easily. Why? See, I told you the platinum wire is there. If you go through this picture, you will see that a platinum wire is there, which is wrapped and dipped in that particular hydrochloric acid. Then what will happen? It will produce the hydrogen gas, and hydrogen gas used as the electrode here. Okay, so this is the what I told you, that picture is in front of you. Okay, so actually hydrogen is gas, so we cannot use the gas as the electrode. Okay, hydrogen can release electron. Do you know that? That is behavior of a hydrogen H plus. Okay, so that we can use this one. Next, hydrogen electrode is inconvenient for use in practical routine laboratory experiment. Yes, so it is inconvenient because hydrogen gas is highly explosive in nature. That's why that needs some that is essential precautions. Just a second, please. Okay, just a second, please. Issues. Okay, so as you know that hydrogen gas is highly explosive in nature, it is not convenient to use in the routine laboratory. It requires large gas cylinders. So it has got the following practical problems, right? It requires a large gas cylinder. hydrogen and air mixture is slightly highly explosive. That is the main issue. Okay, catalyst is easily poisoned. Okay, means that poisoned. You see that there is a word poison. Don't think that this is the that is in chemistry that for the catalyst, two things are used. One is poison and second is promoter. Okay, why I'm telling this terminology most important. So why poison here? Poison means it reduce the behavior of a catalyst. Which reduce the behavior of a catalyst is known as the poison. Which enhance the behavior of a catalyst is known as the promoter. So catalyst two types, one poison and one is that is your what is promoter. So it is main issue of hydrogen that is electrode. Standard hydrogen electrode is hydrogen gas is highly explosive in nature. So as you know that chemistry lab is vulnerable in the case of this explosion and all the things. So that's why we should be careful. Neither it will be happen something. So in the MCH-1 we should be we understand that what kind of precautions we have to use. So that's why. Then second thing is calomel electrode. What I told you already, I taught you in the calomel electrode. Already I taught you calomel electrode. What is that? What type of things you have to use in that particular slide? Okay, calomel electrode. Saturated, normal, deci normal, whatever may be, that is value is given. I have given the 0.02, 0.21 and 0.33. Okay, so that value is given there. I taught you already. There is no issue. So next, silver calomel. Okay. Now we'll come to the indicator electrode. Indicator electrode already I have told you. Indicator electrode, which electrode you are indicating. An indicator electrode of the cell is one whose potential is dependent on the activity of the particular species whose concentration is to determine. So that is what the definition of this one. You have to understand these things. I just have explain all the indicator electrodes like your okay. Then now we'll come to the mercury electrodes. Another important second order electrode used for the measurement of the EDTA. EDTA is ethyl trimethyl amines, and its anion is Y4 minus. Is based on the response of the mercury electrode in the presence of a small concentration of a stable mercury Hg. Okay, EDTA complex. I already explained this one. Mercury electrodes, all the things. So you have to go through this one. Okay. Next, membrane or ion selective electrodes. I have given that that is facts about the membrane and ion electrode, ion selective electrodes. Okay. Now the point is here. The thing is that determination of equilibrium constant. Okay, this area you have already I told you, but see this one. So this is another area where you can that derivation may the questions will come. From electrode potential measurement, we can calculate numerical values of many equilibrium constant such as the solubility, product constant, dissociation constant, and formation constant. Right. So one important advantage of this method is the measurement can be made without disturbing any equilibria that may exist in the test solutions. Nothing will be disturbed. So that's why it is an important method. So del G gives free energy is equal to del naught G plus RT ln. Then all the reference and things are given here. Okay, all the reference and things are what you have to use. Okay, so del G is equal to del G naught plus 2.3303 at T log K. K means this is the constant value. Okay, so the value will be calculated and this is the K value log K. Okay, and see that where K is the equilibrium constant. So in equilibrium that condition del G is equal to 0 always del G is equal to 0. So del G is equal to 0 means what will happen then del G naught is equal to minus 2.303. This is 303, not 3 actually, 303 at T log K. Okay, this is the from that equation number 2.39 we got del G naught is equal to minus 2.303 at T log K. Okay, So according to the equation 1.24, okay, del G naught is equal to minus NAP. This is the actually Gibbs free energy. This equation tells the Gibbs free energy. Del G, you have to memorize these things. Del G naught is equal to minus NF E naught cell by minus E naught cell. So minus N means number of free electron, F means Faraday's constant, E cell is equal, E naught cell, you know that value of E naught cell potential constant. So combining these two, now in replacing the del G naught, we have put down N minus NF E naught cell is equal to 2.303 at T log K. So log K value will be minus NF E naught cell divided by 2.303 at T. Substitute by F, R and T value. You know that F is a constant. So that is 496 or 96500. That is volt coulomb. And also that T R value is 8.343, and also a T value is equal to 278 Kelvin. So if you calculate these three things, and 2.303 is there also, so you will get the most that value is there 0.0591. So N E naught cell, this is log K value. So you find out the what is dissociation constant. Okay, determines the equilibrium constant. Sorry, equilibrium log K is equal equilibrium constant. So you find out the equilibrium constant value. This is very simple derivation, but you have to understand that the formula and all things. Okay, so now this part is over. We'll go down to the next, potentiometric titration. Okay, potentiometric titration. Actually, some of the that I have not seen them, their name in the MCH-1, but they have later joined or something else. They have not joined in that class. Okay. Okay. Now I'll come down to the potentiometric titration. All of you should notice this. All of you should see the this equipment. All of you just see this equipment. Okay, this is the apparatus. This is the potentiometric titration apparatus. So one Coulomb electrode is there. Second indicator electrode is there. Burette is there. And there is a magnetic strider there which can vibrate this one. Then iron meter with millivolt scales. Means a small amount of energy is essential. So iron, that's why. Okay, this is the equipment you have to use, and the burette you have to take the things which one value you have to find out. Then accordingly you have to check it out. Okay. Okay. Now it will come the situation where that potentiometric titration we can apply. So it is mentioned in the second paragraph. Potentiometric titration may be applied to a variety of systems, including those involving oxidation reduction, precipitation, acid base, and complex equilibrium reactions. I told you this one. This is the area where you can use the potentiometric titration. Okay. Second thing is that potentiometric endpoint detection also provides more accurate result than the corresponding method employing indicators. So it is a particularly useful for the titration of the colored and opaque solution for the detecting of the presence of suspected species in the solution. So this is the use of, that's why it is working. But the titration, how it will work? Okay, now the thing, the titrant is added in a large increment at the outlet as the end point of approaching, as the indicator, whatever, maybe the increment has made the smaller. Sufficient time must be allowed for the attainment of the equilibrium. So as it's a slow reaction, you have to give the time should be more. As you know that a titration is a time-taking procedure. Increment the adding of the reagent. Precipitation of reactions may require several minutes for the equilibrium. Then particularly in the vicinity of this equivalence points. So it is close to that situation, and it will provide you the number of commercial potentiometric titration units are available, which comprise an electrode system frequently. Okay, frequently a selection of electrode is offered together with a special and stand providing supports for the electrodes. So these are the process and the location of endpoints. So how does it works? You have to read this one. So there is no, you have to go through this one. How does it work? It is explained over there, and in the practical you will do that. So types of potentiometric titration: one is neutralization titration, second is your oxidation reduction titration, third is your precipitation titration. These are all the titration you have to do: complex permission titration and differential titration. So that is in the case of your that is, if you will come down, neutralization titration. Potentiometric neutralization titration are particularly used for the analysis of mixture of acid and polyprotic acids or bases, because of a discrimination between the endpoint of the endpoint can often be made. So here strength midpoint can be calculated. It means it is acid, right? So there is a minus and H plus, means if we take the HCl acid, so H then plus and Cl minus. A is the Cl, means that is the acid part of that one. So strength of that one, if you find out equilibrium constant, so H plus, concentration of H plus into concentration of A minus divided by concentration of HA plus. I told you this in the first MCH-1. So on the basis of that, you have to find out this calculation and all the things. Okay. Now if you come down to oxidation reduction reaction, indicator, you have to use indicator which is oxidized and it changes the color of this one substance. And indicator electrodes for the oxidation reduction are generally fabricated from platinum, gold, mercury, or silver. That is the metal, because it is noble metals. The metals chosen must be on-reactive. That's why I told you noble metals, non-reactive metals. So that's why it is platinum, gold, and mercury. So the components of the reaction, it is merely a site of electron transfer. Platinum electrodes is most widely used for the oxidation reduction titration. Okay, these are the things you have to read this one. Okay, there is no need to. You will go through this all the things. Then these are the terminal questions. What is an electrode potential? We have discussed about what is the absolute value of electrode potential cannot be zero. Why? Why the absolute value? Because if absolute value would be zero, so that there is no potential difference will be created, right? So that's why absolute value G not value del G value should not be zero. Okay, that's why. G value is already means sorry, free energy value will be maybe del G value will be zero, but absolute potential value should not be. But potential value will be zero, so then that is electron donation or acceptance will not be happen. What is reference electrode? I told you. Explain liquid junction potential. Already we have discussed about that. What is standard cells? All of these, they are there. So these are the things. Answer is there. Okay, go through it. Next, we'll go the next unit, and that will be tomorrow, not today. Today is not possible. If anyone has any questions, you may ask. Okay. Thank you for joining. I'm leaving right now. Okay.
Okay, sir.